I know I've given you some definitions for physics before, but in a way, physics is really the study about how stuff moves. And if I want to define physics as how stuff moves, the technical terms we use are stuff. Really, the better word for stuff is matter. Does that make sense? And when stuff moves, it moves because it has some sort of energy that causes it to move. So, I mean, I know the technical definition of physics is the study of how matter and energy, they work together. But if you want to put it into, like, people words, physics is all about how stuff moves. And I like this unit because I see a lot of real-world applications to physics. You may not ever be a physicist, but hopefully you'd agree that, like, this information, this matters to somebody somewhere. Might not be you, but hopefully you can agree that, like, what we're doing here is purposeful somewhere in the world. So let's start with a few word problems. Really, they're actually all word problems. So here's an example of what we're going to do next week, Wednesday. Let's say we take some Hot Wheels, we run them down a track. The track is 825 feet, and it happens in 450 seconds. We want to find a speed. So first thing we need to do is we need to identify which formula is the most appropriate. And to be honest, so far in physics, I've really only given you about 3 formulas. Today I'm going to add 4 more formulas to the list. So, like, it will become more challenging to know which formula to use.
I barely know the first 3.
Okay, well, that's what we need to work on then, right? So, the first formula then that we need is V equals change in D over change in T. And I'm not going to put the little arrow hats on top because we don't actually have a direction here. So all we need to do is take 8.25 feet and divide by 4.50 seconds. By the way, I'm going to try to do some of the work on my my graphing calculator off to the side here, just so that you guys can see what I type in. Out of curiosity, who uses a graphing calculator like this one here?
I think I do, but I don't know.
Okay. You don't have to. Like, you can do it with a regular old-fashioned calculator too, but I thought I'd just show you the calculator as well. So 8.25 divided by 4.50.
That's 2.
Ooh, thank you. Good catch. Okay. Rather than write this number down, 1.833333.
Is that like a FaceTime thing or what? I do have your calculator.
It's a computer program.
Oh.
Yeah. It's a computer program. So the point I wanted to make here is we got to round this number. How many digits do I get to round it to? 3, I believe, because 8.25 has 3 numbers in it. 4.50 has 3 numbers. One of them is a 0, though. However, the 0 is on that side, whatever that is, the right side. And that does count as a digit. If the 0 was on this side of the number, it wouldn't. So 3 digits. So my final answer is 1.83. And I need some units. Well, now it's feet per second. Yeah, because you see how the unit here was in feet, not in meters? So I know that normally it's been meters per second so far, but I can change the units on you. Not everything gets measured in meters. It could be millimeters or feet or yards or miles or... Sound pretty straightforward? All right, second question. I like sports and physics. So if you're particularly a boy, boys and sports often go together. Girls do too. I don't mean to be sexist, but, like, you know, sometimes this is a real... Physics works for sports. I don't know. So you're throwing a ball at 34 meters per second.
That's very slow.
Well, actually, 34 meters per second is actually quite fast.
34. Oh, I thought it was
Like, it's going 34 meters in 1 second. So think about how far 34 meters is. That's got to be at least the classroom, right?
That's fast.
Right? At least the classroom, if not maybe the whole hallway. And you're throwing it that whole distance in 1 second. So.
Holy.
Okay, that's slow.
I thought it was 34 miles per hour.
Now, 34 miles per hour is less fast then, yeah. So, okay. Where was Mackenzie going to? Okay. Sorry, I just saw her walk away. I didn't know where she was going. Okay. This speed right here, 34 meters per second, is actually the V in the formula. So we actually have the answer, 34 meters per second. And I also told you how long this took. it took 3.8 seconds. How do I solve for D? Can I just take two numbers and plug them right in the formula, or how do I like rearrange it?
We'll do the both sides.
Yeah, we're gonna have to multiply both sides by 3.8. Does that make sense, by the way? I always feel like when I teach physics at first, I feel inadequate because I don't teach you math as well. So I hope that you know algebra skills. Like I'm looking around the room, that does make sense? Okay. So this side over here cancels.
A little bit.
This seconds right here actually cancels with that seconds right there. What is the unit left over? Meters. Because it's the unit that didn't cancel. And we just got to take 3.8 and times it by 34. So 3.8 times by 34. You might be inclined to say that it traveled 129.2 meters. Yeah, okay, we need to watch our rounding. I know that this number didn't just go for forever and it actually stops at the nearest tenth, but technically we need to base this on precision. One of these numbers was measured using 2 digits. Another number was measured using 2 digits. And we have 4 digits. So what we need to do is keep the 1. That needs to be kept for sure. This 2 right here is the last digit I can keep. But it's actually going to round up to 3. But, okay, 129.2 is not 13. Okay. So there was a trick we used to kind of fix this. Good, well done. We need to times it by 10 to the 2? No, just 10 to the 1, actually. Yeah, we need to add an extra 10 on it. You were really close, though. Like, you had the right concept. Yeah. Do you guys get why I had to spend a whole day talking about this extra, like, scientific notation thing?
Yeah.
Like, I need to do it first rather than doing it as we talked about this. So this would be how many meters it was. There's a couple other options, by the way. You also could have written it as 1.3 times 10 to the 2 meters. That would also be valid. There's actually more options. Does anybody have a data table nearby that tells me what a 10 to the 1 is? I don't happen to have it nearby, but like there's, you know what I mean? Like a kilo or a centa. It's like a deca. Deca is 10 to the 1. What's the prefix for deca? Is it just D?
Yep. Go DA.
DA. Okay. So this one right here, rather than writing the 10 to the 1, I could have said it was 13 deca meters. It's like you're saying a bad word almost. What's a 10 to the 2, by the way? It's like hecta or something like that, maybe?
What's that?
What's 10 to the 2? Hecto?
Yeah.
And that's the prefix for hecto. HA? Just H. Okay. So this one right here you could have written as 1.3 HM. You could have called it hectometers. All 4 of those answers I would accept as correct. That makes sense? Now, when you guys do my tests, sometimes there'll be multiple choice, sometimes there'll be numeric response. You might, in your calculator, think that this is the right answer. But if that's not one of A, B, C, or D, you know how I make a multiple choice? This one right here might be the one that I put as the right answer in A, B, C, or D. So I do need you guys to know that all of those are equivalent to each other and make sure you can pick out which one actually fits. Does that make sense? So please make sure that if that didn't make sense to you now, talk to me later so I can remind you how the whole, if there's a 10 to the power of something, how that works.
I understand that, but I just don't understand when I have to divide times.
Okay, so the idea behind dividing times is if you're going from a base unit.
So what would be a base unit say?
So a base unit would have just been meters.
So a Hot Wheels car runs down 8.5 foot track.
Here, let me give you an example here, Gabe. Seconds is a base unit.
Yeah.
Milliseconds or microseconds or megaseconds, that's not your base
So
unit.
then when we're going in, when we already have something, we're going into something else, we divide.
Well, if you're going from a base unit into something else, you multiply. And if you're going the other way, I believe it was dividing.
Okay, so if you go here, you start with the base, not a base unit, then you go into Like,
Can we write this down later? Okay. Sorry, I don't. We can talk more individually in a bit. Okay, let's do the last example then. I need an eraser here. So maybe you're not a person who loves sports the same way I do. Like I said, for me, sports is the thing for physics. I know not everybody will be that way, but hopefully you can appreciate that this last example, maybe you're a world champion yodeler. Yeah? Oh, you're right. I didn't actually put a direction on the last one, did I?
Yeah.
Yeah. I would probably say after I did displacement of the ball, we should probably say towards home plate. That would be a good direction to use. So you might just need to write it out in words. Thank you, by the way. It said displacement for the ball. Displacement does require a direction, so you should say towards home. Okay. Where was I? Last example. Maybe you're not a sports person. That's fine. You hopefully still appreciate that physics is useful somewhere. So you're a yodeler. The speed of the sound you make is apparently 340.29 meters per second. It's actually very fast, which makes sense because when I talk, you hear it basically instantly. So let's say, though, that it's not from me to you away. Let's say that we're actually a long ways away. Like we're talking some guy's on top of the Swiss Alp mountain, and he's yodeling. It's going to take a long time for that sound to actually get to the bottom of the mountain. That's actually how you hear like the echo effect, is because it's taking a while for the sound to catch up. Makes sense? So, I have a problem right off the bat here with this unit. That unit's in kilometers. And this unit right here is in meters per second. Those two units don't fit.
So you divide.
So, if you have this many kilometers, maybe another way of putting it is that you actually have 2.5 times 10 to the 3 meters. Because a kilo means it's a 10 to the 3. That's how many meters you have. Basically, it's 2,500, yeah. So on this one, actually, Gabe, we're supposed to multiply to go from a unit with a prefix in front of it to the base unit. You multiply. The other way, you divide.
Okay.
So this is how many meters we're talking about. So our speed is equal to distance and time. Our speed is 340.29 meters per second. Oops. That's supposed to be an equal sign. And it's going to equal 2,500 meters over time. I'm going to go full screen here. There we go. Does that make sense so far, plugging those two numbers in? Okay, so again, back to algebra skills, where again, I feel like I'm getting the impression you guys seem to know what I'm talking about here. So we need to get t by itself, and the biggest problem with t by itself here is that it's actually on the bottom of the fraction. So we need to multiply both sides by delta t, so that now delta t is no longer on the bottom of the fraction. Delta t is now on the top, but it's on the other side. Sometimes when I do this with my high school kids, so long as they get the concept of algebra, I just draw an arrow to just imply that it's going from the bottom of one side to the top of the other side. You guys ever do that in your math classes? You're allowed to do that in your math classes, or do you have to show the steps all in between?
You gotta show all.
Okay. I mean, for me, so long as you get the concept of what's happening, I'm okay if you just kind of draw a little arrow and say, hey, the t is going up here. Now t is no longer by itself. It's actually next to the number 340.29. So I've got to divide both sides by 340.29. What should happen is this side over here, all of this cancels. And in my calculator, I have to take 2,500 and divide by 340.29. Now I need to round. How many digits do I get? Well, based on this number right here, this 2500 looks like 4. But keep in mind, that is actually not the number we started with. It was actually 2.5 kilometers. The original number I gave you only had 2 digits. We kind of made it look like it had more digits so we could type it in our calculator, but 2.5 kilometers is only 2 digits of precision. So this final answer right here should only have 2 digits as well. So 7.3. Does that make sense? You need to be careful with digits. I always recommend go back to the original question. This one had 5. This one had 2. So 2. One last point I want to make. In terms of units canceling, there's a meter right here and a meter right here. They cancel. And the unit that's left then is seconds. So, how long does it take for a yodeler's voice to get all the way down the mountain? 7 seconds. How'd I do? Does that make sense to you guys? Is that good review? I'm glad. That's good. Because now it's going to get harder. Well, it's not going to stay easy forever. Whoa. I'm back up.
It's like, make it not hard yet.
Okay, so my goal today now is we're going to add a new variable. So far, we've really only talked about distance or displacement, velocity, speed, and time. Now we need to add a new variable to the equation, and the variable we're going to talk about now is called acceleration. You guys probably know this word. Like, acceleration is basically how fast are you speeding up. Sometimes it's better to think of acceleration as the opposite. What happens if you're not speeding up? You're slowing down. Yeah, sometimes we use the word decelerate. That would be like when you stomp on your brakes. When I have a vehicle that I'm driving in the snow on ice, I just bought new winter tires for my car the other day. I want them to be able to decelerate quickly. Does that make sense? Because when I need to stop my car, I want it to stop. And I want it to stop quickly, not slowly. Does that make sense? I want my car to come to a stop as fast as possible so I don't get into an accident. That's deceleration. Or acceleration then is like if you're trying to, say, race vehicles, not that you should, but whoever's vehicle gets up to speed quickest, that's acceleration. So technically there's actually 2 ways to accelerate an object. We're mostly going to focus on the first one though. You change the object's speed. If you take physics 20 with me, we can actually accelerate objects by changing their direction. Most of the time when you do that, it's because you're spinning something in a circle. If I spin something in a circle, it's never going the same direction because it's going this way, and then it's going this way, and then it's going this way, and then it's going this way. Does that make sense? And maybe you've heard the term like centripetal force or centripetal acceleration. Things that go in circles have a specific physics to them, and they have accelerations. So even though they might not be changing speed, if you change a direction, technically you change its acceleration too. But we're going to focus mostly on changing a speed. So here's the formula. It actually looks kind of similar to one of the ones we've just been using. Rather than doing velocity right here and distance and time here, we're actually going to put acceleration here and velocity there. The way acceleration works then is it's measured in meters per second. You guys see how there's like 2 different slash lines in the units? When we talk about the units for acceleration, we say meters per second per second. It's a weird unit. It's meters per second, your speed, per second. That's the unit for acceleration. It's like how much extra speed do you get every second? Or how much less speed do you have every second? Sometimes we write it like this, though. We go meters per second with a little 2 up in the corner. You guys know what that means, like squared?
Yeah.
Okay, so either I'll say meters per second, or I'll say meters per second squared. That's the units we use for acceleration. Okay. One more thing about acceleration. Acceleration, we're going to put the little hat on top of it because it should have a direction attached to it.
Looks like the arrow going forward.
Yeah, you can use like a little arrow. Some sort of little notch marking, though, indicates that there is actually a direction applied to it. If you were accelerating forward, it means you're speeding up. What if you were accelerating backwards?
Speeding down.
Yeah, you might be slowing down. Speeding down. Alright. I found this little animated GIF down here to maybe help illustrate the idea behind acceleration. Which car had the highest acceleration right off the bat? The red one. Does that make sense? Like right off the bat, the red car is the one that it just gets out to the early lead.
But then that other one's turbo.
Okay, so difference between these two things here. Red has the fastest acceleration. It gets up to top speed at the fastest. However, the blue car at the bottom looks like it actually has the... Yeah, the blue car at the bottom might actually have the fastest velocity because it ultimately is going faster than the red car. It just took a while to get there.
Turbo, man.
Does that make sense? So, I mean, imagine you've got two cars racing each other. One of them has a top speed of 100 kilometers an hour. Another has a top speed of 200 kilometers an hour. Okay. The top speed of 200 kilometers an hour, it takes them a while to get there, but once it's going 200 kilometers an hour, it's going really fast.
I think the green car has the highest velocity.
My favorite's not moving.
That's funny.
Let's do an example. Sorry. Next time I'll make sure it's animated for you. Alright. By the way, there was a second formula for acceleration listed on your formula sheets. It looks something like this. Acceleration is equal to a velocity 2 minus a velocity 1 over a time 2 minus time 1. Do you guys have that formula listed?
Oh yeah.
Okay, that's another formula for velocity where if I tell you a start and finish velocity, and I tell you a start and finish time, we can try to figure out acceleration. So, let's try this one here. The car starts from rest, accelerates for 12 seconds. However, what we actually care about is only the time frame from the 5-second mark to the 8.7-second mark. So in this second formula, I'm going to use 8.7 seconds and 5.0 seconds as the two time values I'm given.
Doesn't matter which one you use.
So long as you're consistent and you make sure you do the big one minus the little one.
What's V2 minus V1?
Good question. Let's keep reading. Well, the car changed speed from 15 meters per second to 27.8. So what was the second velocity of the car?
28.
The 27.8, yeah. What was the first velocity?
12.
Oh,
Oh, 7.8. X5 15.
there it is. Yeah. Does that make sense what I just did there?
No.
I actually threw bogus information into this question. Did we ever use the 12 seconds?
Nope.
Throw you off.
I guess in a way I could give you a question that says a baseball pitcher lived for 92 years. Oh, and by the way, when he threw a ball, it took 12 seconds for it to go 5 feet. Did the 92 years that he lived for actually make a difference in the question? Well, that's kind of this question here. Sure, the car was traveling for 12 seconds, but the time frame we cared about was from only the 5-second mark to the 8.7-second mark. So I want to warn you guys, sometimes in a question you might get extra information that you don't even need to use to solve the question. This 12 seconds was actually not relevant. So, okay, we just need our calculators now. I'm going to take on the top of the fraction 27.8 minus 15, and that's going to give me 12.8 meters per second. On the bottom of the fraction, I'm going to take 8.7. I'm just going to subtract 5.0. That's going to give me 3.7 meters per second. And then last step, I'm going to take 12.8 and I'm going to divide by 3.7.
Don't the bottom just be seconds?
Oh, good catch. Thank you. At the bottom is just seconds. Thank you. Good catch. Oh, used a bigger eraser. I shouldn't have used that. What did I say it was? 3.7 seconds? Everybody okay with that point up to there? Alright, now for the details. My calculator spit out an answer of 3.45, blah, blah, blah. We gotta figure out where do we stop the blah, blah, blah and end it. Did that make sense, by the way? Is everybody getting that when you try it? Is everyone actually trying it in their calculator? Okay, good. I hope you are. So, how many digits do I get? 2 only. Yeah, 2. The lowest number of digits is what you get. You see how 27.8 has 3 digits? That's awesome. Unfortunately, 15 and 8.7 and 5.0, they all have 2 digits, so I only get a 2-digit answer. So this is going to be 3.5 meters per second squared. Pause and watch this for a second here. You see how this is meters per second? But then there's an extra second on the bottom. Technically, we're dividing by seconds 2 different times, so I'm going to square that. One more thing. Acceleration should have a direction. Now, it didn't tell me the direction here. I just need to use common sense. Forward probably makes the most sense.
I didn't get any of that.
He's going forward, right? He's speeding up in the forward direction. You guys good? Let's try another example. You have a boat. The boat is able to speed up at this rate, 4.5 meters per second squared. So that's like how fast it can speed up. Let's say it undergoes a change of 18.5 meters per second. How long will it take to undergo that change? So, I think in this formula here, we should use the first one, where we just do acceleration is equal to our velocity over our time. What's our acceleration?
4.15.
Now, I'm not going to mark you wrong if you did this, but technically this should probably have a direction as well. I feel like forward is kind of redundant, though. But, I mean, maybe we'll just write it down anyways. He's probably going forward when he's driving. I know it didn't say that, but I think we can assume that. It also, I know it gave me a speed.
Why'd you go 5.2? 5 squared.
Oh, that's seconds
Oh.
squared.
What's that little 2 besides that?
Squared.
So that's 5. That's seconds, not 5.
That's a seconds. Sorry. Hard for me to write on this thing, okay? You guys tested it out. It's not that easy. Okay. Our velocity was 18.5 meters per second. I know it said speed right here, but I'm feeling pretty confident that if you're driving in a boat, again, you're probably driving forward in the boat. So I'm just going to throw an F on the end of it. And what we don't know is time. We've been here before. How do I solve for time? Okay, so I got to multiply up the t, and then I've also got to divide away the 4.5. If this starts to make sense to you, I'd be fine if you just went right to this. Your change in time then is going to be the 18.5 meters per second forward. And it's basically switching places with the 4.5 meters per second squared forward. I like to draw just a little arrow here, kind of implying those two things are switching places. And I hope that makes sense to you with an algebra point of view, like how you use your math skills there. Let me just make this full screen so you guys can see better. Any questions on that part so far? Before you type it in your calculator, I just want to point out what's going to happen with all of our units. The forward signs will cancel, which is good because can time have a direction?
Yeah.
Not really.
The end of time.
Time goes, I guess also technically goes forward, I guess, but in a different way than a boat does. This meter right here will cancel that meter right there. You know how we write seconds squared? I'd actually like to change this and write it as seconds over seconds. Just to illustrate a point here, meters per second is a valid way of writing this. The reason why I want to write out both seconds is that this second right here can then cancel with this seconds right here. What is the only unit I didn't cancel? Yeah, there's one remaining second, so my answer will be in seconds. I just need to know what 18.5 divided by 4.5 is. 4.1? Okay, so then we only get 2 digits, so 4.1. far, so good? All right, let's do one more example, then we'll take a break, and we'll finish the rest of the notes after a break. So let's do one last example. Let's say that a car applies its brakes and changes its speed. We want to determine the acceleration of the car. One of your first challenges sometimes will be figuring out what formula should we use. We've got three different numbers here. We've got a meters per second, we have a second meters per second number, and we also have a 5.2
So that's
seconds.
2 meters per second where that cancels each other out.
Yeah, in a way, we have to kind of subtract them from each other. I'd like to use the last formula then. The acceleration is equal to your velocity 2 minus your velocity 1 over your time 2 minus time 1. I want to use that formula there. What was my second velocity?
60.
Actually, technically the 12.2 is actually the second velocity, is it not? Because he was starting at 16 and ended up at 12. By the way, what is happening? Is he speeding up in this example?
No.
He's slowing down. He's decelerating, yeah. So I should actually start with the 12.2, what he finished with, and the V1 should actually be what he started with. Now for another point I want to make. We technically need two different times to go in this formula, but I only gave you one time. Well, I didn't actually just give you one time. If I really wanted to do this, I could say when I first started, it took 5.2 seconds, and the initial time that we started at was actually 0.0 seconds. Like, I know it didn't say 0 seconds, but it kind of implies that when he started, it was at 0. That's when he started braking. So there actually was an extra number for time, we just never said it. Okay, so now for our calculators. We need 12.2 minus 16.5. The top of my fraction, I got negative 4.3 meters per second.
Yeah, same.
What does the negative imply?
We decrease.
Slowing down, yeah. Okay. The bottom of the fraction, I don't think I actually need to subtract 0. I know it's going to be 5.2 seconds. That's a really bad seconds. Let me try that again. 5.2 seconds. So let's take negative 4.3 and divide by 5.2. I got an answer of negative 0.826923 or so.
But 8.2.
So we get 2 digits, 3 digits, 3 digits. So 2 digits when we're done, because we're dividing. Does this 0 in front count as a digit?
No.
Okay. So I think this is what you said, Gabe. It'll be negative 0.8. The 2, though, goes up to 3. Good. Meters per second squared. And I want to throw a direction on this. And this is a really key point here. When you are hitting your brakes, your car is still going forward. However, your acceleration is pulling you backwards. Okay, I want to give an example here. Imagine that you're like a skydiver, or maybe you're like a drag racer, where they pull like a parachute behind you. You guys get the concept where you pull a parachute? The idea behind that is that it's trying to actually pull you backwards to slow you down. However, are you still going to be, like if you're free falling because you're parachuting, you're still going down. Does that make sense? However, your acceleration is attempting to pull you back up. So it is possible for you to go forward, but have your acceleration be pulling you backwards. So make sure you're clear on this. I'm going to put a B for backwards. You are being slowed down in the opposite direction. The negative kind of implies that anyways, doesn't it? The negative kind of implies that you're getting slowed down. Sorry, that's really ugly. I should really put the B in a better spot there. B for backwards. Give me one more thought, and then you guys can take a break, and we'll finish after the break. Because I do have more examples after this, right? What was that? Yeah, so let's take a break in a second. Okay, so here's my last slide. we now have 4 variables we can work with. Distance, displacement, speed, velocity, acceleration, and time. There are more formulas that can actually shove all of these variables together, and those are the next 2 formulas on your list we're going to talk about. D equals like BFT plus 1/2 AT squared, and D equals VIT 1/2 AT squared. See those bottom 2 formulas on that first column? That's what we're going to talk about after you take a break, where we're going to put 4 variables all in the exact same formula. Okay, so go take a 5-minute break, and then when you come back, we'll try the next formulas that look like this. Okay, can I snag your attention back, guys? Okay. Hopefully you're finding that physics so far is going pretty good. I hope you're enjoying. I mean, it's not hard yet. Physics is probably one of the hardest sciences, and I have a couple of reasons why. Although maybe it's going well so far, we're really working with just we're only working with a small number of formulas. I thought I'd show you guys what the Physics 2030 formula sheet looks like. You guys have a small fraction of formulas to work with, and honestly, for what I even have on the sheet there, you've so far learned to work with like 5, 6 formulas. That's one of the things that's going to make physics very challenging, is that, yes, you have to be good at math. That's a big part of it. But another problem is you have to have good interpretation skills and problem-solving skills to figure out what formula should I use. Because there's more than 5. There are many. No, you guys don't have to memorize these, but you do need to be able to know how to use all of them by the end of the year. And that's a bit of a challenge. So I don't want to discourage you because I want you to do well, obviously. One of my goals, though, as a teacher, can I get your guys' full attention, please? Thanks. One of my goals as a teacher, though, is to try to help you figure out which sciences you want to continue on in. And hopefully after teaching you chem, hopefully you have an idea of, yes, I like chem, no, I don't want to do chem. One of my goals will be the same for physics. I want to help you figure out whether physics is what you want to do. So I don't want to give you too much of a false sense of security. We've only started with just the very easiest of formulas. There are many more. Okay, so.
In grade 10?
Well, we're only going to do a small section in grade 10. Only the ones on your sheet in grade 10 are we going to do. But hopefully you guys can see, like, there's way more than that. Okay? So, I don't want to discourage you. I just want to let you know that this is only just a small little bit of what physics is going to look like. So. Okay, so let's add 2 more formulas to your list. We've talked about 4 variables then. Speed and velocity, distance and displacement, time and acceleration. There are now a couple of formulas we can add to the list that actually don't just have 3 variables. By the way, do you guys know what I mean when I use the word variables? Letters, that'll work, yeah. All the previous formulas only ever had 3 letters in them. This one now has 4. So here's the 2. If you know distance, velocity, time, acceleration, and you actually have to use time 2 different times in this formula, then this is a formula to use for you. Or this other formula is very similar, only there's one slight difference. This one has a little I, this one has an F. Anybody have any idea what I and F stand for? Initial? And final. Okay. When we talk about things that have a speed, you don't ever drive the same speed the whole time. Sometimes you speed up, sometimes you slow down, right? And so in these formulas, a slight distinction is about, are we talking about the start speed, the initial speed, or are we talking about the end speed, the final speed? Often, the initial or final speed will be 0. Like, for example, if you start at rest and speed up, your initial speed is 0. Or if you slow down, your final speed might be 0. So one of the hints I'm going to give you is that sometimes it may seem like you don't have enough information, but you may actually have a hidden number in the example, which is that is actually a 0 for one of the examples. So let's do an example. Here's a train. A train can decelerate at a rate of 4.5 meters per second. And I actually really need to change that number. if something is decelerating, I shouldn't just make the number be 4.5 meters per second. I should really make it negative 4.5 meters per second because it's slowing down. Okay. So that's how fast the train can slow down. Josh, I feel like I'm not getting your full attention. It's like 4 times in 3 minutes.
Okay, I'm at 3 times for 10 seconds.
Okay. We've also got time right here. 20 seconds. And we're going to slow down to a speed of 2 meters per second. Our question is, how much stopping distance will the train need? How much distance will the train need as it starts hitting its brakes for it to get to that final number there? Because imagine you're a train coming into a station. You have to know when should you start hitting your brakes so that you don't slow down too soon or you don't go reaming in there and crash into something. So one of the things I like to suggest then, let's just write down what we know. Okay? We have an acceleration of negative 4.5 meters per second squared. We have a time, 20 seconds. We have v for speed of 2 meters per second. But I need to be more specific. In the little corner here, I'm either going to write an I or an F.
I right now because it's not the final.
Well, actually, it says we're slowing down to a speed of 2 meters per second. So he was initially going way faster than that, and he was slowing down to like maybe you're going through town. The train shouldn't go ripping through town, right? So it's got to slow down to a reasonable speed. This looks like it's its final speed, at least for now. It may speed up again later, but for now he's got a final speed of 2. And what we're looking for is a distance of some type. So, new challenge. Which formula is most appropriate to use based on the information we have? I guess for this formula here, it looks like we need that guy right there. Okay, so let me write it out again. Distance or displacement is equal to a final velocity multiplied by the time it takes. We're then going to subtract, is that right? Yeah. 1/2 of our acceleration. And then we need to take our time and square it. Can you guys see how this all of a sudden got a lot more complicated? Yeah.
What's that line at the bottom?
Walk me through. Here, here.
I'll tell you. A little bit further. Right there.
This is 1/2.
Oh.
That's a half.
What is that?
Okay. Well, this one's actually, fortunately, at least we don't have to do any algebra on this one. We can actually just plug a whole bunch of numbers in. It's going to look like this. Our velocity final is going to be 2.0 meters per second. And we're going to multiply. Do you guys know that when I use like a dot, it means multiply?
Yeah.
Okay, good. I don't like to use an X sometimes because sometimes X implies a different letter. So I'll use a dot. We're going to times that by 20 seconds. And then we're going to subtract 1/2 of our acceleration, which is actually a negative. So I'm going to just put it in a bracket here. It's negative 4.5 meters per second squared. And then after that, I need my time, again, 20 seconds. And do you guys know how a squared sign means that you times by itself?
20 times 20 then?
That's what I'm going to do. I'm going to write 20 times 20. Like I said, physics starts off not so bad. I kind of like build your confidence up, and then I slam you with a question like this, where it's like, whoa, where did these numbers come from? So I want to focus on this now in 2 sections. Is everybody okay so far with just plugging numbers into my equation here?
Yeah.
Okay, this is a 2-part equation then. This stuff right here that I'm going to highlight in blue is a term that I'm going to put together and calculate. And this stuff over here in yellow is also a term that I'm going to calculate. So I'm going to do this in 2 stages.
What's on the top?
So the first thing I'm going to ask you to do then is take 2.0 meters per second and times by 20 seconds, which I don't even think you need your calculator for. 2 times 20.
22.
40.
22.
2 times 20 is 40. Does that make sense? So this little number in blue right here is going to be 40. Watch the units though. This second and that second cancel, leaving us with a unit that is meters. Now I'm going to put a subtract sign, and I'm going to put all of the stuff in yellow together. So I'm going to do 1/2. I'm going to times it by negative 4.5. I'm also going to times it by 20. And I'm going to times it by 20 a second time.
So you get 50.
I got negative 900.
Oh,
That actually sounds right.
Anybody else get negative 900? Whoa, what did I just do there? So 1/2 times negative 4.5 times 20 times 20 is negative 900. I want to walk through a couple of things that should happen with the units now. Do you see how right here you have seconds squared? Another way of writing that would have been seconds over seconds. I'm just going to remove the squared sign. This seconds can cancel with that one. This seconds can cancel with that one. What's the unit that I have left? Meters. Just meters, actually. And the number was negative 900. Last question. I hope you guys know this. What happens when you subtract a negative? Okay, you guys know that you add when you double subtract? Like I said, physics and math, there's such a huge overlap of skills. You now need to take 40 and 900, add them together. You're going to get 940 meters. 940. Is that the right answer?
Not done yet, but.
Well, actually, just ask for a distance. So we're good on this one. We don't actually need this distance. But I do need to make it into 2 sig digs. So either do 9.4 times 10 to the 2 meters, or you could write it as 94 times 10 to the 1 meters. Either of those would be acceptable, but don't leave it as 940, because that shows 3 digits, and we weren't supposed to have 3 digits based on all the measurements we took. This one was 2 digits, this one was 2 digits, this one was 2 digits. This one right here has 3.
Could you do 90?
Times 10 to the 1? That's another way of doing it. Does that work? Julian, could you do me a favor? Could you just close the door? They're going to be banging away out there. Just got one last example then. Oh, go back? Yeah, for sure. Everybody good? Okay, but you got it written down though? Okay. Because I can give help for sure. Alright, one last example, then I'm done for the day. You're a parachuter, and you deploy your parachute at 1.53, watch the units here guys, 1.53 kilometers above the ground. That's not going to work if we just leave it as kilometers. We're going to have to do a conversion later. I'll do that later. I'm going to keep reading here. He decelerates at a rate of 6.3 meters per second. Again, you got to watch the wording here really carefully. If I say that we're decelerating, this number right here really needs to be a negative 6.3 because we're slowing down. We also have a time. Time is 25 seconds. This time around, we're looking for a velocity, but we're looking for an initial velocity. So you don't have to do this, but I always recommend, once it starts getting more complex, write down what you have. You have a distance of 1.53 kilometers. That's not going to work the way it is. So before I go any further, maybe I should write it as 1.53. What is kilo as a prefix? Times 10 to what?
3.
Okay, so kilo is times 10 to the power of 3 meters. Or another way of writing this number is 1530 meters. There's the number we're going to have to use now that it's in meters. We also know an acceleration. Technically, it's not an acceleration, it's actually a deceleration, which is good because I don't know about you, but when I'm free falling with the parachute, I'd like to start slowing down, please. Otherwise, I keep speeding up and I go splat, right? So make sure we use a negative number, negative 6.3 meters over seconds. Time, 25.7 seconds. We're looking for a velocity initial. Is that clear so far? Oh, do you need me to scroll back up?
Why is it you just use what?
What was that? Well, like, this is the one right here we're going to use. Because I couldn't use this one because it was in kilometers. And I changed the kilo, the K, into a 10 to the 3. So that I have a number I can actually work with. So, need my next formula. Distance is equal to velocity initial times time plus 1/2 of AT squared. This one's not as nice as the last one. Last time we were solving for D, and D was already by itself. This time we're not solving for D, we're solving for VI. So we need to work on our algebra skills. I guess I'm closing the back door too. Thanks. That's VIT plus 1/2 AT squared. That's the other formula that's on your list that we haven't used yet.
Yeah.
So now we're using it. So here's my recommendation. Let's start plugging in what we know. Do we know our distance?
Yes.
I'm going to go way down here just so I have lots of room. My distance was 1530 meters. I knew my distance. Then the equal sign. Did I know VI? Okay, so I'm going to leave VI as a variable. That's the one thing we don't know. Next, do I know time? I do. It was 25.7 seconds. Then I'm going to add 1/2. And it needs to get multiplied by an acceleration. So I'm just going to use a bracket here. It was negative 6.3 meters, seconds, and seconds. I'll just write it out twice there. And then time was 25.7 seconds. And another 25.7 seconds. We just kind of topped from like level 1. Yeah, like it got a lot harder, a lot faster. Like just all of a sudden it was like, it was easy, and now this is a lot more challenging. Because there's a lot more numbers everywhere. I'd like to recommend then, and do the same thing I did last time. I'm going to highlight different sections of this. Right over here on this side is a section, the 1530. That doesn't show up very nicely, does it? Let's use a different color. We'll use yellow. Right over here, there's 1530. That's kind of like a section of this equation. And right here is a section of the equation. And right here is a section of the equation. Does that make sense so far? Okay. Which section should I work with first? Anybody have any ideas where I should kind of start? It's actually the green one. Yeah, all of these numbers in green here, I can multiply them together, so I feel like I should. And before I do that, I just want to show you what the units will be. Here's a second sign. It'll cancel with one of them. Here's another second sign. It'll cancel with that one. So once I'm done typing all these numbers together, the unit that's going to be left here is going to be meters.
Okay, what did we just do?
Okay. I took one of each of these seconds that was down here, and I canceled them with each of the seconds up there. The only unit left now is meters. Now I have to multiply all these numbers together. So we need 1/2 times by negative 6.3 times by 25.7 and another 25.7. Negative 2080.5435. I'll write it out here. Negative 2080. 2080.5435, I think it was. Is that right? By the way, this is a really important note. Don't round. Not until we're done. We will round eventually, but we shouldn't round until we're done everything. Does that make sense? It would be like, let's say you go to work, and the first day you worked for 8 hours, the next day you worked for 8 hours, the next day you worked for 8 hours, and at the end of the shift, at the end of the week, you worked for, 50 or 60 hours. But your boss decides to round every day you worked and said, well, 8 hours, actually that rounds down to 0. And the next day, 8 hours rounds down to 0. And the next day, 8 hours rounds down to 0. Would that be fair to do? What you should really do is you should add up all your hours first. And then once you've added them all up, then if you have to round, then that's the time to round. Does that make sense? So you shouldn't round as you're going because you're gonna lose accuracy. So make sure you keep on to all these digits. Even if there's a whole lot of them, you should keep them all. Okay. So now I'm going to rewrite this. It's 1530 meters equals VI times 25.7 seconds. And now we're actually minusing this number. All right, next algebra skill. I want to get this VI by itself. It's attached to a 25.7. However, there's also a 2080 meters over here. This number right here that we just solved, we have to get rid of it. To get rid of it, I need to add 2080.5435 to both sides. Does that make sense? The idea of how you need to add it to both sides? So right over here, the 2080.5435, it was there, and I've subtracted it. Now it's gone. Can these two numbers actually add together? Why? Good. That's the point I want to make. You will know if you make a mistake if, like, this is a meters and this is not the exact same thing. Because you can add meters to meters, but you can't add meters to seconds. Does that make sense? Like, they have to be of the same kind of unit. So these two numbers should be able to add together. So let's do that. They have to be of the same type of unit to add them together. So then I have to add, what was that? It was 1530. So now I've got 3, 6, 10. $54.35 meters. Does that make sense how I've added these two numbers together here to give that one? What's left on the other side then? Well, VI multiplied by 25.7 seconds. Good. Now you need to divide by 25.7 seconds. On both sides. Now, just a second ago I told you meters can only add with meters. However, when you're dividing, you actually are allowed to divide different unit types. When we're done, what unit are we going to have? Well, this seconds will cancel. The unit you'll have when you're done is this meters will divide by this seconds right here. So our answer will be in meters per second, which is good because that's typically what we measure speed in. Oh, wait, that's not VF, that's VI. So this side over here should cancel. And now you're left with this number here divided by 25.7. There's our final answer. Wow, we still have to clean this up still though. I got 140.4880379. I want to make sure I'm very clear. We should not have rounded a single digit until we were done. That makes sense? Like, it would not be fair to round before we're finished everything. So now we're finished, now it's time to round. Let's go back to the original question. This had 3 digits. This had 2 digits. This had 3 digits. So the lowest is 2, I guess. We were doing multiplying and dividing at some point, so that's how we base it. So this number here of 140,
14.
we're going to have to write it as 14 times 10 to the 1, or 1.4 times 10 to the 2 meters per second. Either of those would work.
How do we change that?
So, like, I guess if I wrote it out, I could write it out as 140.488. And then in terms of digits, I get 2. So I'd keep the 1. The 4 I'd also keep. But is 140 the same thing as 14?
No.
Okay, so we'd need to, like, times it by 10 one time. Because, like, 14 times 10 would give you basically 140. But this now is only showing what we consider to have 2 digits rather than 3. Or maybe another way of looking at it, you can move the decimal place over once or even twice. And that's why this has been moved over twice. We're still not done. So I know I never actually maybe said the direction all the way through, but we just got to use our own common sense. Which way is the guy probably going? Yeah, down is probably logical. So I'll just save some room here. He was going down. All right, out of curiosity, give me a thumbs up or down or in the middle. Were you able to follow that?
Now,
Okay, so I've got a big spread here. Was the difficulty the math
Oh, what?
on this last example
It's
here?
just knowing what to use.
Okay, I would say, in my experience here, this is where, like, this is the jump in physics. It used to be reasonable, and all of a sudden, it's not as reasonable anymore. And the hardest part is probably math skills and guessing. It might not be math skills, but that's usually the divide. Here's where we go from today. We're done for the next little while. Tomorrow, Flex Friday, is like a work day, study day. You guys can go wherever you want. I don't care what you do. But if you're struggling, you should definitely chat with me. We need to work together, okay? So, things to work on then. One more minute, guys, before you're completely not paying attention. Things to work on. You do have an assignment to work on, but you probably are only going to do about 8 assignment questions. If you want more practice on this, here's a slide that has all sorts of different textbook questions in various different places in your textbook. Okay, so snap a picture of that with your phone if you want more practice. You have about 10 minutes left today. Do what you want, and then you have tomorrow as well. Monday, the next time that we really meet together, Monday's a quiz. Okay?
Well, we have more of those to do.
Yeah, I can find one.
Out of the way, Jake.
On your website, is there those things?
Yeah, there's one listed on there.
Website?
Yeah, should be like one of the first things on there.
How do I print it though?
What do you mean, like just to the printer? Or?
Yeah, it's just like a big paper.
Oh, I know what you mean. Here, let me print you one. I'll just print the big print downstairs. I can do that.